Redox reaction involves transfer of electrons from one species to another. Chemicals are separated. You can monitor the redox reaction and electrons flow through an electric current. Electric current is proportional to the rate of the reaction. Fundamentals of electrochemistry. Some of the basic concepts. A redox reaction is an analytical technique based on the transfer of electrons between an halide and titrate. It is generally termed as reduction and oxidation reaction. A substance is reduced when it gains electron from another substance. Gain of electrons or net decrease in the charge of species. It is also called as oxidizing agent or oxidant. A substance is oxidized when it loses electrons to another substance. Loss of electrons or net increase in the charge of the species. It is termed as a reducing agent or reductant. The following is a simple example or representation for the oxidation and reduction, where Fe plus 3 acts as an oxidizing agent, Cu plus acts as a reducing agent. Some of the basics. Oxidizing agent pulls the electron. Reducing agent pushes the electron. The push or pull is called as a cell potential, also called as electromotive force. It is represented in volt, or that is equal to 1 joule of work or coulomb of charge. It is measured in 1 voltmeter. Now, how to remember very easily the concepts? So, simply you can write oil rig. Oxidation involves loss, reduction involves gain. One more thing is LEO in GR. Loss of electrons, oxidation, gain of electrons, reduction. So, you can have an idea about where the oxidation takes place, or for example, if oxidation takes place or electrons are produced, anions migrate towards the for a negative sign. This represents the anodic port or anode, where in cathode reduction occurs, electrons are consumed, cations migrate to it has a positive sign. Next, let us take a simple example for electrochemical cell that use an oxidation reduction reaction to generate an electric current, are known as galvanic cells or voltaic cells. It is made up of two half cells, zinc sulfate, zinc electrode, copper sulfate with copper electrode. Oxidation, loss of electrons occurs at the negative electrode. Reduction, gain of electrons occurs at the positive electrode. This salt bridge acts to complete the circuit by joining two half cells together. So it maintains electrical neutrality to minimize polarization to avoid liquid junction potential. Now, how will you represent the cell reactions for in anode? Zinc gives rise to Zn 2 plus 2 electron. At cathode, copper plus 2 electrons give rise to copper. The short notation for this cell is zinc dipped in zinc sulfate solution. It is separated by a salt bridge, copper 2 plus and copper. So anode on the left, cathode on the right. Is the signs and notations which is followed in the IUPAD. The cell potential E is a measure of how well a cell reaction can push and pull the reaction through a circuit. The electrical energy is generated by a spontaneous reaction that is proportional to cell potential. A standard cell potential is measured when all the species are in standard state, that is given by E naught cell is equal to E naught of cathode by E naught of anode. Now, more negative E naught, what happens? More easily electron is added, more easily reduced, it is a better oxidizing agent. More positive E naught, more easily electron is lost, more easily oxidized, better reducing agent. So, these are the some of the examples where we can understand the very basic fundamentals about electrochemistry. The references is Introduction to Electrochemistry by Samuel Glasstone. Thank you.